Good morning, everyone.
Good morning.
We have discussed in the last class
Flags that are
TCP headers, UDP headers, then flags of the TCP, handshake process, three-way handshake, four-way handshake, and cables, right?
Yeah.
Okay. So today we'll start with the boot process. See, to understand this, we have two types of memory, right?
Yeah.
If we talk that how many types of memory we have, so it is going to be of two types. What are the types? No. One is called as a volatile memory.
Volatile, non-volatile.
And one is called as what?
Non-volatile.
Non-volatile memory. And what is the differences between them?
Volatile memory stores the data for a long time, and non-volatile memory does not store the data for a long time.
accessible.
And access will be yes.
It means which one is permanent.
So volatile is permanent.
Non-volatile.
Volatile is temporary memory and non-volatile is a permanent memory, right? Volatile means what? It can be deleted whenever there is power off and on situation is there. So let's say in a memory you have stored something and after some time there is a power off connections. And if again power on is there, then whatever you have stored in that type of memory, if it is deleted, that is an example of volatile memory. It means this is a temporary memory. And in non-volatile, what happens? Whatever we have stored, it is going to be permanently present in that. It is not going to get affected based on the power off and power on situation. That is called as a non-volatile memory. So example of the non-volatile memory are ROM, then NVRAM, flash. Example of volatile memory is RAM, random access memory, right? So what happens that whenever we start the devices, whether it is a switch, whether it is a router, it does not matter. Both follows this boot process. So in this, what happens? First comes the ROM mode, that is called as a read-only memory. So what happens that whenever device is getting started, so it does power on self-test. What it does? Power on self-test. What does it mean? That it will check the power connectivity between the devices, whether I'm receiving the power or not. Then after that, it will check the hardware connectivity. It means what all the devices has been connected with me, that it is going to check, right? So power on self-test, then hardware connectivity. This is called as what? This is called as a bootstrap. Bootstrap is what? Power on self-test and hardware connectivity checking. So what happens that first it is going to have this read-only memory. See its purpose. So it says that purpose is to store the router's bootstrap program, which is an initial program that runs when the router or when the switch is power on.
That boot process means they are router.
I'm not telling routers. It can be any other devices. Whether it is a router, whether it is a switch, they both can perform this boot process. No? Whenever the device is getting started, what are the functions it will follow, that we are discussing. So when the device we are starting, what it does first? First, it does bootstrap program. In the bootstrap, what it does? It checks power on self-test, whether the device is receiving the power or not. Second, what it checks, what all the different devices has been connected with that particular device. If let's say router is there, so router will check what all the other devices has been connected with me, right? So, okay, whenever the device is getting started, always it is checking the same thing. It is not that today it will check, tomorrow it will not check. It is not there, no. It means whenever we start, it will check this all these things. That's why it is stored where? In the read-only memory. And this is what? An example of what? Non-volatile memory. That is a permanent, right? So whenever the device is getting started, it does the same thing. That's why we call it as a non-volatile. Functions provides the instruction for the router to start up and load the operating systems. And read-only memory stores what? Bootstrap or boot helper, we can say, program that is loaded when the switch or router is first power on. Okay, it can be any other devices. So here what we are checking in the boot process, power on self-test, hardware connectivities, right? Next, it will check for the software components. And software components, it is going to check in the flash memory. So what is the purpose of the flash memory? It stores the routers or switches in iOS, that is called as a Internetwork operating systems and other system files. So whatever the software components that we have on the devices will be stored where? Flash memory. And flash memory is also example of what? Non-volatile. So what it does, it allows the router to load the iOS from the flash memory during the boot process. Flash memory stores fully functional Cisco images and the default location where the devices get its Cisco iOS, that is called as the operating system boot type. Flash memory can also be used to store any other files, including the backup of the configuration files. So we can say for storing purpose of the files or for storing purpose of the iOS, what will be used? Flash memory will be used. ROM will be used for what? Hardware, power on self-test, bootstrap programs. This one will be used for what? Software components. Next is what? NVRAM. What is that? Non-volatile random access memory. What is the purpose of for this? It stores the router startup configuration file. See, now what happens that let's say you are having a router, correct? On that router, what you did, you have assigned one password, enable password or login password. Now, whenever you are assigning any password, that is what running configuration. Running configuration means what? Whatever I am like giving the commands on the routers or switches, it is called as running configuration. So running configuration is stored in the random access memory that is called as a RAM. Now, if you have given certain commands and if you have not saved that, so it will be there in the RAM only. And if whenever there is a power off and on situation, what will happen? Whatever the command that you have given will be deleted. Now we want that, okay, whatever the command we have given, it should be stored permanently. So for that, you have to give one more command that is called as a WR. That is called as what? Write up command. When you will give this write up command, after all the commands that you have given, all the commands will be saved, right? And if it is saved, where it is saved? In the NVRAM. So when it is temporary, it is stored where? In the RAM. Whenever you are saving that part, it will be stored where? In the non-volatile random access memory. Right? Now what happened that, okay, you have given enable password. Then you have saved that password. So it is there in the NVRAM. So whenever you will start the device, it will always ask you the password. Why? Because that password you have given and even you have saved. And if it is saved, it is stored where? In the NVRAM. That's why it says that it stores routers startup configurations. Or what is the function of this? Function is the startup configuration is loaded into RAM during the boot process to configure the router, and non-volatile stores the initial or startup configuration file that is used when the device is powered on or when the switch or the router is first reloaded. Again, we have started that. So that's why, let's say, for example, you have given the password. Now you have saved the password. So it will be in the NVRAM. Whenever you will start the devices, it will ask you the password. If you will forget the password, let's say you forgot the password, how to access the devices again? Then we have to do the password recovery. And to do this password recovery, we have to bypass this NVRAM. If you will bypass this NVRAM, you will directly land into the RAM and it will not ask you any password there. This is the process of password recovery. We'll do one day this password recovery. Okay. So RAM, what is the purpose? It stores the running configuration files and it is what? Other temporary data. Now, what is the function? It holds the active configuration and operational data while the router or any other switch is running. So it is also important. See, why RAM is very important. Whatever the configuration that you are running on the devices, if everything will be stored permanently, then what will happen? If you need to give new commands, it will create certain problem. No, you have to delete old commands. Then only you can execute the new commands. That's why it is also very much important to have certain thing as a volatile that can be deleted. right? So here also it is written that RAM is for what? Work, that is a working memory and running configuration. Flash, Cisco IOs, that is software. ROM, bootstrap program. NVRAM, startup configurations, right? It is a type of memory in which whenever there is power off and on situation, the files in this type of memory will be deleted, and it is temporary memory. Example can be random access memory, non-volatile memory, so it is a type of memory in which whenever there is power off and on situation, the files stored in this type of memory will not be deleted, and it is permanent memory. What can be the example for this? NVRAM, ROM, flash. Clear? So this is called as what? Boot process. Next, see, whenever we will use any routers or switches, any devices, so it is going to have certain different modes. So when you will start the devices, first it is going to show you user execution mode. And to identify whether it is a user execution mode, this is the symbol. This, right? This is the symbol to know that this is a user execution. This user execution modes provide you limited access to basic monitoring commands. Means you can just see what all the functions is available on the devices. You cannot do much changes on the devices. Same as we have one mode that is called as a privilege mode or in the enable mode. And here the symbol is hash, this one, right? This this mode allows you to use the commands. Like for example, show IP interface brief, show IP route, show running configurations, show MAC address tables, everything. So this can be used to view the commands. But here also the same thing, that what is the limitation? You cannot do much changes on the devices using this particular enable mode or privilege mode. It can called as a enable mode also, or it can be called as a privilege mode also. Correct? Now, to make certain changes on the devices, you have to come into which mode? config mode. That is called as a global config mode. So in the global config mode, it is used for configuration purpose, for making changes on the devices, for assigning IP addresses on the interfaces, for doing routing, everything. Everything can be done where in the config mode. So broadly, when you like talk how many modes we have on the routers and the switches, so broadly we have user execution mode, privilege mode, and the global config mode. Then this global config mode has been further divided into multiple different modes depending upon what the functions you are using there, right? For examples, here we have enable mode. Then we have given the command here configure terminal, and we came to global config mode. Now in the global config mode, if you're going to assign interface numbers where you will be assigning the IP addresses, then you will come to interface mode. Global interface mode, config interface. That is config if mode. Then if you're assigning VLAN, then you will come to which mode? VLAN mode. If you're assigning line console, you will come to console line mode. If you are assigning line VTY, you will come to VTY line mode. You understand all the uses of this, right? So same like we have one global configure terminal, but it can be further divided into different modes based on the type of functions that you are going to execute, right? So we understand all these modes practically, and we'll see what all the functions can be used and what all the changes we can make using the config, right? See, so here we have, these are the routers. See here, this is what it is written as a network devices. Here we have all the routers. Then this is the switches. This is the router. This is the switches. And here you see end devices. These are the end devices, PCs, laptops, servers, everything. So now let's say we'll take a router first. So we'll use here this one, 2911 series router. Okay. So click over here, just put it here. Now click on the router. You will come to CLI. So it is loading here. Now boot process, correct? Booting. Device is booting. Now it says that would you like to enter the initial configuration dialog? What we have to give here?
Yes.
No. We have to give no. Now, if you want to give yes, then what will happen that we have to see. Let's say you have given yes. If you will have, you will give yes, what it will ask you, would you like to enter the basic management setup? It will ask you to give a host name to the router. If I don't want to give, then it will ask you to give enable secret password. At least you have to give the passwords. What it says, no defaulting is allowed. It is mandatory you have to give, right? Now you can give, let's say admin 123 you have given. What it says, now you give enable password. Now it is telling you to give virtual terminal password. I don't want to give. What it says, no defaulting is allowed. It means this is mandatory, you have to give. It means that if you will give yes, you will be in the control of the devices. Device will not in the your control. That's why you have to give no. If you will go give no, what will happen? You will decide whether I have to give the password or not. You will decide whether I have to give enable secret password or not. Everything. But if you will give yes, it will ask you to give. It is mandatory. That's why what we have to give? Always no. Correct? So now come to CLI. We have to give here? No. When you will give enter, you will have to come, you will come into which mode?
Router.
Router user execution mode. See the symbol. What is the symbol says? This is a symbol, no? This symbol represent what? This is a symbol, user execution. What it says, it provides you limited access to the basic monitoring of the commands. Let's see that. Give a question mark. These are the commands that can be present here. So like disable, connect, exit, enable, log out, ping, resume. So like this. Okay. These are the basic commands. You cannot do much changes on the devices using these commands, right? What is the use of this session number? See, session number means like whenever, let's say this device, this particular router is being accessed virtually or remotely, means from any other place with the help of certain protocols. So each users will be getting a session number because see, let's say we have 10 users. So that particular 10 users can execute 10 different commands over there. So how to identify that this command has been executed by this particular number or users based on the session number that will be given to the each separate users, right? And when we are going to have this all these things, when you have multiple users to access that same devices, when then only, right? So now, as you can see here, that we cannot do much changes on the devices using all this particular execution mode commands. So we have to come into the enable mode. What is the process to come to enable mode? Just you have to give here en, right? So you came to enable mode.
Yeah.
Same here also you can check with the question mark command. What are the things we can do? See, extra thing you can see here. Clock time you can set, clear. Then you can do debugging of the debug command can be used to check what all the things is running in the background, right? Then delete, then disable it. Generally, we will be using this particular enable mode commands or enable mode to check all the functions of the routers or status of the running configurations. Example, let's say you want to check how many interfaces we have on this router. How will you check? Show IP interface brief. You can use full form also, but we can go with the short forms. SH IP interface brief. Show IP interface brief, give question mark. It's give enter. It is showing you that we have three different interfaces with this router. We have not assigned any IP address on the router, right? And this is down, and this is talking about the villain number one. Correct? Now, if you will give command show run command if you are giving here. So it will show you what are the things is running on this devices. But as we have not given any command, that's why it is not showing you. See, no IP address, no IP address, because we have not assigned any IP addresses on the router's interface. Correct? Now, for example, if you have taken one switch now, now tell me to connect router and switch, what type of cable you will take? A straight through or crossover? Straight through. That's why I'm telling you. Now see, we can use here straight through cables, but we will be using here automatic cable. What is a requirement for this? See, for example, let's say you're using a straight through. So it will ask you to select the port numbers always. Right? It is asking you. Same here also will use. Correct? But if we will not use this, here we have one automatically chosen connection type. So we'll use this. In real scenario, we don't have this type of facility. Here we have in a Cisco packet tracer. So let's remove this connectivity and connect using this cable, right? Automatic cable. And see now it is not going to ask you anything. Just it will directly connect. Here also same thing. Right? Now, as we have connected here, so we have our interface G0/0. Here we can assign the IP addresses, right? So come to this router. So you know that in the enable mode, we cannot assign the IP addresses, right? We have to come to in the config mode. How will you come? Config space T. See, you come to config mode, right? Now, let's give our name to this router, host name. So host name, what name you want to give? Router 1. Okay, R1 we have given. Now the name has been changed,
Okay.
right? Now it is visible also. What is the interface number? G0/0. So interface is G0/0. Enter. Then we have to assign the IP address on this interface number. How will you assign? Let's say IP address. Then see, you have to always use this tab button, tab. Let's say you are writing here IP. I have given IP and I will just write A. And if you'll use tab, it will take automatically all. Okay, IP address. Then let's say 192.168.1.1. Then, okay, see, if you have given IP address and if you give a question mark, what it says, give here A.B.C.D links IP address 32 bits, or you can give here IP address DHCP also to get automatically. But as we don't have any server yet and we have not created DHCP, that's why we cannot take IP from the DHCP. We have to manually assign here. So what we will do, we will assign it 192.168.1.1. Then again, you give a question mark. What it says, you have to give your subnet mask. Let's say we have taken /24. So what is subnet mask for that? I have taken /24. What is subnet mask?
24.
255.255.255.0. Correct?
Yes.
Next, you cannot give directly exit. You have to give here no shut. Why? Your interface is down. See, it is in the red color.
Yeah.
It means it is down. You have to give here what? No shut. When you will give no shut, see your interface become up. Green means up, right? Now give exit. You have assigned the IP, right? You have to verify whether the IP that we have assigned is present or not. So I told you that whenever you have to check anything, you have to be in which mode? Enable mode. But if I have to check from the configure mode only, how will I check? Just one word you have to add, that is called as a do. For example, when we have given this command in the enable mode, we have given show IP interface brief. But when you are in the config mode and you have to check the same thing, then just you will give do show IP interface brief. That's all. What will you give? Do show IP interface brief. For checking purpose, do will be added in the config mode. Given, now you check. What is it in here? Interface number. Then this is the IP we have assigned. Now what is the status of that particular interface? Up. And protocol is up. Correct? See, now let's say you have given this. Now come to this particular PC. Okay, let me write all the things here. See, this is a node. You can place a node on this. What all the IP we have given? So 192.168.1.1/24. And here 192.168.1.2/24. Right? Now you come to the switch now. Or let's say on the switch also, generally we will not assign any IP on the switches, but how to assign that we are seeing 192.168.1.5/24. Okay. So come to the switch, CLI, give enable. config space T. Now, how will you check? Same thing, do show IP interface brief. Do show IP interface brief. Now, as you know that switches has more numbers of ports, that's why it is showing you all this number of ports. Correct? Total how many? 25, 26, 27. See, even these are the ports also. It means we have fast Ethernet ports and even the gigabit Ethernet ports. Means we can have both the ports on our devices. Fast Ethernet also, gigabit Ethernet also. So now if you have to assign the IP on the interface, let's say you want to assign it on the F01. Let's check whether we can assign or not. Interface F01, IP address, let's say 192.168.1.5, 255.255.255.0. What it says? Invalid input detected. Why? It means that on a switch interface, we cannot assign the IP address.
Yeah.
Right? If it is saying you invalid input detected, then it means that we cannot assign the IP on the switch interface. Where we can assign? Router's interface. So where we will assign the IP on the switch interface? On the interface VLAN. Where will you assign? See, what it's telling you that we have this all ports on the switches. How many VLANs is running over there? Only one. And what is that VLAN number? 1. It means by default VLAN number 1 will be there, right? Okay. So give exit now and give here interface VLAN 1. Now you assign same IP address 192.168.1.5.255.255.255.0. Give enter. Give exit. Again you verify. Do show IP interface brief. Right? It means where we can assign the IP on the switches? VLAN. Now, one more thing. Now, I want to assign the IP on the interface number. Then, for that, you have to give here interface F01, no switch port. No switch port mode access. Then IP address 192.168.1.10.255.255.255.0. Okay. On the physical interfaces, when you will give this command, no switch port, and then if you assign the IP, we can assign the IP. It will work on the real devices. The scope packet tracer has certain limitations also. Some of the command it does not support, right? So if you want to assign the IP on the interface of the switches, it is possible, but for that you have to give this command, no switch port. If you're giving this as a no switch port, it means you're telling him that do not act as a switch. Now you have to act as like a router. That's why you have to assign the IP addresses. Correct? So generally, we have to assign where on the interface VLAN number. Okay, on the switches. Clear, no?
Could you summarize?
I will write all the commands. Don't worry.
Just the process.
Which one?
No, the whole process. Can you summarize?
All this.
Just the process in the diagram. All the process.
Means you want me to tell you again how to assign the IP on the switches. Yeah. Okay. So it is on the interface VLAN number. Okay. See, you will check first do show IP interface brief. So when we have given this command do show IP interface brief, it will tell you, it will show you all the detailed information regarding how many interfaces number we have and what all the IP has been assigned over there, right? So when you will check, we have interface numbers. Apart from that, we have a VLAN number 1, right? So by default, a single switch will be having a VLAN number 1. We can create multiple VLAN also. We'll come to that part later on. So by default, we have VLAN number 1. So when you will assign IP on the any of the interface numbers, it will tell you invalid input detected. It means it says that we cannot assign the IP on the interfaces of the switches. So where to assign? On the interface VLAN number. So when you are assigning the VLAN number, by default, what it considers, all the port is having this IP 1.5, because all the ports is belonging to a single VLAN that is called as a VLAN number 1. Okay, so it means we are assigning the IP on the group, VLAN groups, and where we have given the IP. If you want to assign IP on the specific interface of the switches, for that you have to give interface number, then you have to give no switch port, and then only you can assign the IP on the physical interface of the switches. That can be executed on the real devices, right? Understood now? Now come to this PC. Come to this PC, desktop, IP configurations. Now see here, it is telling you two options, DHCP, static. What we will use? Static. Now what it says, you have to assign the IP address. What is IP? 1.2, 192, 168.1.2. Submit mask. Automatically it is taking because it is belonging to class C, right? Default gateway will come to later on. Okay. Now we have assigned the IP like this. Now you tell me, all this IP 1.1, 1.5, 1.2/24 is a part of which network? What is the network address of all this IP? Tell me fast. Hmm? .0. Correct. It is 192.168.1.0. You know how? It means you have not revised submitting. I am sure.
Default.
/24 it is. /24 means what? 255.255.255.0. When you will calculate, you will find that this is the 1.0 is the network address of this all IP. You want me to solve or it is fine? Only one time I'm solving. Okay. See, 192.168.1. Let's say 1 only, /24 you have taken. Now you know that this is /24. It means what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. What is the value? 255 dot 255.255.0. Block size means 256 minus 0 is equal to 256 only, right? Then you will write the starting number. No need to write all this sum networks and everything. 192.168.1.0 to what? 192.168.1.255. Why? It is 256. I am starting at 0, ending at 255. I will get 256. Now you tell me, the IP that is 1.1 will come somewhere in between this. 1.2 or 1.5 will come somewhere in between this. So always, what is my network address? 1.0. Clear? If I will take /26, then my network address may be changed, but it will not change. Because it, again, see, let's say you have taken /26. For example, 26 you have taken. Okay. So what we will get? 192. You will get 64 as a block size. It means for the first, you will have the range 0 to 63. Again, 1.1 and 1.5 and 1.2 will come in between them only. So again, 1.0 will be only the network address. Okay. But if you have taken, let's say 1.50 for this example. So for 1.50 now or 1.70 you have taken. For 1.70 now the network address will be 1.0 only because you have taken /24. But if you take /26, network address will be 1.64 or 64. Correct? No. That's why you have to remember this submitting part. Not forget this. Now come to this router. Enable. See, whenever now we are giving this command, no, enable, directly it is coming to enable mode. It is not asking me any password. So come to config space T. Give here enable password. Huh? Configure terminal. So enable password we have given. Let's say we will give here admin 123. Okay, what we have given? Enable password as admin 123. Now you give exit. Again you give exit. Again you give enable. What it says? It asks you the passwords, right? If you forget, again it will ask you. You're not given. Again it will ask you. How many times it is asking?
3 times.
3 times it will ask. So you have to give this. Now what is the password we have given? Admin 123. Whenever you will type the password, it will not be visible. Okay. Given. Now you give show run. Now when you will give this command show run, your password will be visible. Visible.
Yes.
So anyone can, like you have given the password. Anyone can give this command show run, can check now what is the password.
Yeah.
Right? So how to encrypt that? Means my password should be encrypted. For that, you have to come to config space T and give here enable secret. For first, what you do? You remove this no enable password. If you're giving here no enable password, what will happen? The password will be removed. Am I fast? Huh? You want me to slow? Okay, now we have given here no enable password. Now you give exit here. Again, you give exit. Again, you give enable. Is it going to ask you any password?
No.
No. Why? Because we have removed the password. Now you come to config space T and right here enable secret. And then you give a password, let's say admin 123 only. What we have given, enable secret admin 123. Give exit. Give exit. And again you give enable. It is asking the password. What is the password? Admin 123. Now you give show run. Right? Password is not visible. Correct? Now, question. Let's say, for example, you have given both the passwords, secret as well as enable password. What will be preferred? Secret will be preferred. Okay, let's see. Come to config space T. Now you give here enable password ABC123, right?
Yeah.
Okay, give exit. Give exit. Now give enable. So secret is what? Admin 123. Enable is what? ABC123. We'll give ABC123. ABC123. Not taking. ABC123. Not taking. So if you will give admin 123. Yes. Right? So if you have given both the commands, enable secret, enable password, what will you prefer? Always secret. Show or run. When you will give the show run, see, it's saying that both the passwords are present, but always what is being preferred? Secret passwords. So I think first we will write all the commands, whatever we have discussed till now.
How do we change the password?
Just you will give no enable password
Again, remove it.
and send. To assign IP address on the interface of the router. Enable. Config space T. Interface. Interface number. Like we have given interface and interface number like 0/0/0, correct? Or it can be F0/1, F0/2 like this. Then you will give what? Again, IP address. Then you will write here address. Then subnet mask. Then you will give your no shut. Then you will give exit. To check the interface status, will give show IP interface brief. Okay. In short, what we will write? Show IP interface brief. Same thing is there, but this is in the long form, it is in the short form.
Sir, in Cisco packet tracer, ORA case does not matter.
Huh?
In Cisco packet tracer, ORA case does not matter. Single
Hierarchy.
letter, small
No,
letter.
that's not. Uppercase does not matter. You can use any case. Means uppercase, lowercase.
What will be connected to the devices?
Like you have to check with this. Yesterday I told you, no, that you have to compare like this, whether the cable is matching or not. Color coding.
They are matching is
Color coding is matching, then you have to verify.
this side.
It is there, but in that everything is connected, right? Yeah, see, this is the cable.
Yeah.
If it is matching both the sides, then it is going to be spherical. And if it is changed to one way, you will get different views. From the switch is like that. See, this is what is switch. I see
Yeah.
we have one numbers of ports. That's why we have this is called the switch. This is what? Router. Okay, this is the ASA firewalls. Okay, this is the switches. This is the routers. We have to deal with this. This is what we in our. Okay, so this router has been connected to the switch. Now this is also switch.
Yes, switch it. Switch it, yeah.
Router.
Router. Yeah.
They are four switches there.
Yeah.
Four switches and how many routers?
Four routers.
Four routers.
This side also.
Clear? Yes. Now to assign enable password, what we give? Enable password. And that we have to give the password. To assign secret, enable secret. Enable secret.
Do we need to exit from after that entering
Hmm.
password?
Not mandatory. If you want to add further more commands, you can add directly. Clear till here? Now, see, if you want to assign one banner message on the devices. So for example, you have to come to config space T. How to assign banner message and what is the use, I will show you. First, you will write banner. Then you will write MOTD. What is MOTD? Message of the day. Okay. So the message that you are providing, it should be in the special symbol. So we'll give a special symbol. Let's say we'll give, please allow me to access the router. Any banner message we can give. Generally, banner message is the, you can say details of the devices, or you can say any functions or any, like this router is belonging to any particular company. So it's more to everything will be written over there. So we have given here banner MOTD. Please for allow me to access the router. Give enter, give exit, and again you give exit. So this message is present. This is called as a banner message of the day. This is not like optional commands. These are okay. Same. Then come to enable. Okay. What is the password we have given? Admin 123. Come to config space T. Line console 0 password. Let's say BMW 123. And why we have given this login. What is the use of this password? Line console 0. See, line console means for console means what? Console cable you will be using. So whenever anyone is connecting the console cable to the devices, and if it is trying to access devices, that time only it will ask the password. It will not allow him only to come to enable mode. First time only password, right? So what we have given that password is this one. And when it is going to ask, whenever we are going to log in there, right? So give exit, give exit, give exit. Now see. Asking the password, right? It means just you have connected your devices, it will ask you the password. Even it will not allow you to come to the user execution mode. This is called as what? Login password. What command? Login password it is. So what is the command we have, what is the password we have given? BMW 123. Came to user execution. Whatever the command I'm giving, it can be applicable for the switches also. Okay, switches also same process. Correct? We came to enable user execution mode. Enable. What is the password? Admin 123. Now, why we have given line console? You know that okay, this is console means what? Console cable. If anyone is using, then it should ask the password. What is the number of this zero represent? See, like a line console 0, a single user, if any other users, if it is a single user, if it is going to access, always it will ask the password. That's why we have given. Okay.
If it's one,
See, 0 and 1. We cannot give like directly 1. We have to give it from the range 0 to 1. Okay. It means you're telling that if two person is accessing, two different passwords you want to give. One line console 0 for this one, Line console 1 for this one. When we will start with the VTY, line virtual terminal, there will go with the ranges. Let's say we have given line VTY is 0 to 1, for example. Okay, see, come to config space T. If you have given line and VT, okay, line, if you give line console also, give a question mark, what it says. Only you have to add here 0 in this. Now it means what it says. See, who is going to access your devices physically? Only single users. It can be with any other devices, but from access single only. Now, if you have line VTY, what is VTY? This is not physically, this is virtually. Virtually means what? Using telnet protocols. We'll discuss that also. Remotely access, yes, or telnet or SSH. So in the VTY, you have to provide a range. See what it says. 0 to 15. Let's say you have given 0 to 5. It means you are saying here that 6 persons or 6 this routers can be this router can be accessed by multiple 6 different users. That's why we have given a range from 0 to 5. 0 to 5 means what? 0, 1, 2, 3, 4, 5. It means 6. Always you have to start from where? 0. Multiples. Because physically, one is going to be, yes. Right? We have given this pass command. So note down this command to assign login password. To assign login password. Line control 0, then password, whatever the password you want to give, and at last you will give here login. Clear? So let me show you configuration for the telnet. How we'll access the devices remotely, okay? Or we will do telnet. Okay, we'll understand telnet later on. First, we'll take a switch. We have taken a switch, right? And we will connect multiple devices with that switch, okay? 1, 2, 3, 4, and 5. Now you take this cable. See, whenever you're like if you want to take multiple no, you just click over there and you have to press control. Control and then click. Okay. We have to understand here that we have discussed in the first class that the switch has single broadcast domain, right?
Yeah.
It means what? It means that whenever the switch is receiving any information, it is going to send that information to all other interfaces, right? We'll verify that. We will give IPs to the devices. This is, let's say, 10.0.0.1. This is PC1. This is PC2, 10.0.0.2. This is PC3, 10.0.0.3. And this is PC4. So that's why 10.0.0.4. And this is PC5, 10.0.0.5. Okay. We have to come to the individual PC and assign the IP addresses on the end devices. Come to this PC, desktop, IP configurations, 10.0.0.1. Now this IP belongs to class A. That's why when you will come to submit mask, it will show you just /8. Okay. Same will come to PC2, desktop IP configurations, 10.0.0.2. Submit mask. Then come to this PC, desktop IP configurations, 10.0.0.3. Then desktop IP configurations 10.0.0.4 and come to this one, desktop IP configurations 10.0.0.5, and we have given the submit mask, right? Now you know that we have discussed that if we have to verify whether I'm able to reach from one device to other device, what we use? Ping. What is ping? Hmm? See, what is the meaning of ping? Ping command is used to test the connectivity, to test the connections, latency between the two networks. So the ping command sends packets of information to a specified IP address and then measures the time it takes to get a response from the specified computer or the devices. So ping is what? Ping is a utility. Okay. Ping stands for packet internet gropper. This is the full form of ping. Packet internet gropper. Gropper means to search blindly. It is an utility that is used for checking the reachability and connectivity between the devices, right? It operates under ICMP, that is Internet Control Message Protocol. It operates under ICMP, Internet Control Message Protocol. Then ICMP is a layer 3 protocol. ICMP is layer 3 protocol. Protocol number of ICMP is 1. So whenever you will use a ping command, what you will write, ping, then you will write the IP address where you want to ping. Or you will write ping or the name of the devices or the name of the server where you want to ping. Now question for you, whether can we write ping and MAC address? I want to ping MAC address. Is it possible? MAC address operates on which layer? Layer 2. Layer 2. Ping is then not possible. Now, if you are giving this enable secret password, that is different. And if we'll give you a service password encryption. So in the service password encryption, this is used for encrypting the enable password. Swapna, are you getting? Are you there?
Yeah, Vishal, I'm here.
So when you give enable password and you want to encrypt that enable password, then you give here service password encryption, right? For example, let's say we have given enable password as admin123. Okay, already we have given this. So let me remove this. No enable secret, no enable password. So we have removed everything. Now you give enable password admin123. Give exit. Now you give show run. So okay. Give come to config space T. Give no enable password and no service password encryption. Give X done. Now give enable password as admin 123. Right now you give do show run. Password is visible. Admin 123. What we have given enable password. I don't want to give enable secret, means I don't want to give any new password. I want to just encrypt my enable password only. For that, you will give service password encryption. If you have given service password encryption, now you check do show run. Your enable password is encrypted, right? So you can add one more point in this.
Rather than giving
Rather than giving
that,
enable
we can directly do this one, right? Encryption, service password encryption, right?
correct. So if you want to encrypt enable password, then you have to give the command service password encryption. Means rather than giving enable secret directly, you can encrypt the enable password only. Yes. Now we were discussing about the ping. So we have given here ping and IP address and ping and name. So let's just verify this. Yeah, see what it does also. First see this. So ping is a utility that used to test the reachability of a host on an IP network. It means what it requires IP address. What it does, it sends ICMP echo request packet to the target device and waits for the ICMP echo reply packets. It will send echo request, will wait for what? Echo reply. Let's say you're sending hello to your friend. If your friend is not responding, how will you come to know whether he's reachable or not? It means if we are sending hello, we have to receive hello also, no? Request you are sending, you have to receive a reply also. Then you can verify it is reachable, everything is fine, right? So it provides a simple and quick way to verify the connectivity between the two devices. It is going to measure what round trip time for the packets sent to the destinations and the back. What is round trip time? The time it took to send the echo request and to get back the echo reply is called as a round trip time. Okay. So why do we use this ping? Widely used for troubleshooting the network connectivity issues on assessing the network performance. For troubleshooting purpose, this particular ping will be used, right? So ping, we discussed that it is packet internet drop, uses the ICMP, that is Internet Control Message Protocols, sending a message called an ICMP echo request to another IP addresses, and the computer with the IP address should reply with an ICMP echo reply. Okay. So what it does, it sends echo request and wait for echo reply. Okay. Now the time it took to send echo request and get echo reply is called as round trip time, or in short, we can call it as a RTT. Okay. See what we will do. Here also we'll take one PC. I assign one IP to this. Same network, same network. So IP will be 192.168. Let's say 104/1. Okay. Now come to this PC. Desktop, IP configurations, 192.168.1. Done. Now you try to ping. Okay. Come to simulation mode. We had in the simulation mode. Come to command prompt, ping. What you write after writing this ping? IP address. Okay. What is IP? Let's say I want to ping to this particular PC, 1.2, 192, 168, 1. Now see here, certain packet is going to be generated, right? So we'll come to that part, to the ARP later on. First, we'll understand ICMP. So see, as I told you that ICMP operates at which layer? Layer 3. That's why it is saying you layer 3. What it is saying you? Source IP is what? 192.168.1.4, right? 1.4. What is destination IP? 192.168.1.2. What is the ICMP message type? 8. So what does it mean? What does it mean? Type 8 is echo request. These questions can be asked. How will you verify that this is a request packet? So you will tell the code will be written as a type 8. Type 8 is what? Echo request packet.
So what about echo reply?
We'll discuss everything. Done? Now see. Deliver to the switch.
Yeah.
We'll come to that part why it is broadcasting, because it is of the ARP. First, it will not send the ICMP, it will send the ARP. Okay. This is what? ARP. Okay, let it send it back. First, we will discuss ICMP, then we'll discuss ARP. Yes. So now ICMP will be delivered. Now see. So it says that the source IP is what? 1.2 now. It means this one, this PC, second PC,
Yeah.
1.2. And it says destination is what? 1.4. ICMP message type 0. What does it mean? Type 0 means echo reply. Okay, so write down. Type 0 is echo reply. Same. Here it is source. This is the request. This is the reply. And where it will reach. Okay, finally it is reaching. I'm already telling you that this is a echo reply. Now, okay, this was my positive conditions where I have given the request, I got the reply. What if the device is unreachable, not replying, not responding? Then you will get different type messages. So in this it is written that we can use this ping, this is the command format, ping and destination IP or the host name that we have to give here. And it is telling you that what is the use of this ping, and see here. Ping works on the ICMP protocol. ICMP is a network layer protocol that used to send error messages and operational information between the devices in an IP network. So it includes messages like echo request, reply, destination unreachable, time exceeded, and redirect. Always not only request and reply. It can be other like destination host unreachable. So essential for network devices to communicate the status and troubleshooting purpose. So we discussed that ICMP protocol number is 1. Now, echo request is what? Type 8. Echo reply is what? And see what is it is written. Destination unreachable is type 3. It means that if device is not reachable, then what you will get? Destination unreachable as type 3. So type 3 as destination is unreachable. Right? One more we have redirect type 5. This redirect will be used when you are using that trace route, okay, to change the path. So redirect is type 5 and time exceeded is what? Type 11. See, when you try to ping, sometime you will get time exceeded or sometime you will get destination host unreachable. So when we ping and when we don't get any reply, there can be a two situation. First, you will get what? Destination host as unreachable. So in which scenario you are going to get this destination host unreachable? When the device don't have the information about default gateway. Or don't write like this. Let's say if we ping to the destination, right? And destination is on different network. Okay. And there is no information about default gateway. It means the device don't know from where it has to exit this network to reach the device located on different network. In this scenario, will get output as destination host unreachable. Okay. This is very basic concept. We have to understand why. Generally, we should discuss in CCNP routing, but here only I'm telling you. What is the use of destination host unreachable? It means that it says whenever your devices are located in different network. Okay, for example, let's say this is my router. Okay, this is one switch. Okay, this side also we have one switch. Then one PC. And this side also one PC. This is router 1. Or this is just router. This is S1. This is PC1. This is S2. And this is PC2, right? So now don't you think that here the PC1 and PC2 is on different network?
Yes.
Because I told you know that each interfaces of the router will be acting as a different network. This side is on different network, this side different network. If PC1 is trying to ping to PC2, so if PC1 is not knowing how to reach this PC2, because I don't know the how to exit from this network, what information you will get? Destination host unreachable. If we ping to the destination and destination is on different network and there is no information about default gateway, it means that device don't know from it has to exit this network to reach, or you can add here one more point, from where it has to exit this network to reach the devices located on different network. In this scenario, we'll get the output as a destination host unreachable. Okay. Now, if let's say it knows the default gateway information, but it is not going to get any reply from other PC, then it says request timeout. Are you getting my point? Destination host unreachable means whenever there is a problem from your side, you are sending it. You are only unable to send. No. Request timeout, it means I am sending, not able to get a reply. Then the problem with maybe other side, not my side. Right? Whenever the problem is on the destination side, I will get the reply as a request timeout. I am sending, I am waiting for the reply, but unable to get the reply. Okay. So one more scenario that is called as a request timeout. Okay. What we will write when the device is sending the echo request, but unable to get echo reply, then in this case, it will get a response as output as what? Request timeout.
But how much time it will wait to get reply and then
It is not any that fixed time. It will send just within the second only. It will tell you echo request timeout. Okay, we'll verify now. Till here it is clear, no? So now let's say, for example, come to this device only, come to real time and check here. To see what it says. We have ping 1.2. What it says, it's pinging. How many packet it has sent? 4. In Windows, it will send 4 packets. In routers, whenever you will build from router to router, it will send 5 packets. Okay. So what is the size of the packets? 32 bytes. What is the TTL?
128.
What do you mean by TTL? TTL is time to leave. It is not in the seconds, not in the hours, not in the minutes. Time to means not in the milliseconds. So see, the number of device it will cross without being discarded is called as a TTL value.
I need to leave or leave.
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 Time to leave. Leave. This is called as leave only. Time to leave. I'm not telling leave. LEAV. Okay. Time to leave. The number device, the number of device. Okay. The number of device it will cross without being discarded. It means, let's say you are getting TTL as a 10. 10 means that it will cross 10 devices without being discarded. It means that ping has a capacity that it may reach this many devices. If beyond that, that message will be discarded. It will not go beyond that. This is a use of TTL. The TTL can be varied from the Windows to operating system to the operating systems. In the Windows, you're getting 128, right? When you will try to ping it from the router to the router, the value will change. Okay. So in the PPT also it is written. See, what is the time to leave? See here. Time to leave plays a crucial role in different types of network traffic by controlling how packets remains active before being discarded. Note down this statement. How long packets remain active before being discarded. Done? So let's say you want to ping to any random IP, 192.168.1.1. If this IP is not existing here, what will happen? It will not ping. Give enter. It sends 32 bytes of information. What it says? Request timeout. Why? It means I have all the information correctly here. It is sending also, but that particular IP is not existing here. That's why I'm getting request timeout. It means it says I'm not getting a reply from you. I'm sending. There is no problem from my side. The problem may be other side. I'm not getting a reply. What it says? How many packets sent? 4. How many received? 0. 100 load. 100% loss, right? So now, as I told you, we can also ping to the host name, not only the IP addresses. So let's say you want to ping to any host name. Tell me your host name. Facebook.com. Pinging? Yes, it is pinging. First, what it is finding? The IP address of that particular server. Then it is going to ping. What is TTL it says? 51 here. How much time it took total? Millisecond, minimum is 11 seconds, maximum 15 seconds, average is 12 seconds. 0% loss, it means it is pinging. Again, you want to ping any other websites, let's say pinging, right? It means here it says that your TTL is not going to be fixed. Correct? Next. This is used to check the reachability, to check the connectivity, whether we are able to reach or not. There is one more command, trace route. Trace route is used to show what are the path it is going to take to reach that destination. So what you will write? Traced. In Windows, we give command as a traced. Same, you want to trace to, let's say, google.com only.
It's TRA.
Okay. Or it says maximum of 30 hops. It will cross 30 maximum 30 hops before reaching there. That is maximum. It has to reach before 30 only. So whenever you are finding this information, request timeout, what does it mean? It means that the devices was present there, but it is not allowing me to cross that. The reason can be a firewall is working. Firewall is knowing that, or we can say there could be a router that is handling more numbers of packets. That's why it is redirecting it. Okay. One more reason can be maybe it is denying the stress out commands or ping commands. That's why. This is what? This is the IP now. Let's check. 3.254 it is. What it is? My default gateway. Right? What is the IP of my device? 3.77. And this is what? 3.254. It means whenever if I am trying to reach to the google.com, it is outside my network. And if it is outside network, what I require? Default gateway. That's why first it is telling you that I have to go out from the default gateway. right? Now it reached there. Completed, trace route completed. Correct? Same as you can verify with others also. You can give traceroute command and you can give the IP also, or you can give the host name or domain, we can say. So what is the use of traceroute? So traceroute, the command traceroute command is used to conduct a similar test to the ping, but instead of displaying the time, it is used to show the path to reach the particular destination. Okay. So same here also in the Cisco packet tracer. If you want to verify how I can reach this 1.2, what command you will give? Tracer 192.168.1.2. So what it says, see, it is directly reaching here, no? 1.2. It is going to cross any router?
No.
No. Why?
Same network.
Same network. 1.4 and 1.2 is in the same network. That's why it is not going to cross any of the router. Directly it is pinging. And that's what they're saying you just tracing out to this particular device completely. Okay. So what we will do next, that we will take one more devices here, then different network. Then again, we will try to ping that. In that situation, what is required here? Default gateway. Okay. So yet I have not started default gateway topic. Before that only you are knowing what is the use of default gateway. Correct? Okay. So what are the things we have discussed today? We'll come to this part tomorrow because we have to understand all the ARP process. So in that we have to understand ARP request, ARP reply, then proxy ARP, gracious ARP. Then we'll come to the default gateway. Okay, tomorrow topics ARP, then default gateway, then telnet and SSH. That's all. So today we have completed memory, types of memory, then all the basics commands that we have to give it on the router and the switches, and ping and trace route, right? All this. We will be using this one, automatic cable. Only one cable we will use here, automatic cable. Okay. Any questions? Let me stop the recording first.